So anyway, let's sort of drift into the general presentation. So that's a good lead in, the quills to when did you first get involved with CCS, Peter?
Well, a bit hard to say, but when I took on the job of director of BGS, which was 1990, I was shown around, you know, as you are as the incoming director and so on. And I was shown this crazy program that was going on at BGS at that stage that was looking at carbon dioxide. And, you know, I got really interested in that. I mean, as director, you couldn't sort of get deeply involved in it. But it was, I thought right throughout my time, it was one of the more fascinating parts of BGS. And, you know, so by the mid-1990s, I was going around Whitehall and various electricity companies and so on, banging the drum about CCS and getting very little response, I have to say, at that stage. They didn't really want to hear it. But, you know, by that stage, we'd also got Sleipner just about underway. So that got people's attention. So, you know, I've been involved in it for quite a few years. But I mean, when I returned to Australia in 1998, there was nothing going on here. And so it was, you know, it was a real challenge to get something going. But it also is great when you know that you actually started the thing and got the first meeting on CCS in November 1998, I think, and then grown it from there. So really the base for much of the...
Where was that meeting? Sorry to interrupt. Where was the meeting? The first meeting. Right? Where was the first meeting?
First meeting was in Perth in 1998 when the Gorgon project was sort of, people were talking about, and they wondered whether to grow trees or wondered whether to put CO2 in the ground, this crazy idea that some people had and so on. Mm-hmm. So that was the first meeting that we had. And it's grown from there. Well, it's grown sometimes and it's shrunk other times. You know, it's gone up and down, and we've been through probably 3 cycles now. Hopefully this is the last of the cycles, because this is just going to go up and up and up from here on. We shall see.
And did the CCS sort of link to something you'd done previously in your career? I mean, how did it figure relative to your sort of previous experience, would you say?
When I went back to Australia, I was offered the job of the chief executive of a thing called the Petroleum Cooperative Research Centre. And I said, well, yeah, I'm interested in petroleum, but what I'd really like to do is set up a program in carbon dioxide. And they said, well, why would you want to do that? And so I explained to them, and they said, okay, well, as long as you can get the money in, I suppose that's all right. So we'll offer you the job. And so I then set about bringing the money in, and actually found it fairly easy at that stage because people thought it was new and exciting. And so in no time at all, I was able to get about 10 companies involved in that. And it sort of grew from there. So it's been a growth curve, so that's come and gone. But yeah, it's been very satisfying, actually.
But I mean, what was your first degree? Geology?
First degree was geology, yeah. Yeah. Well, I mean, yes, I mean, that's as good a start as any at Durham, actually.
Durham, okay.
Durham, yeah. Then a master's at ANU and then a PhD at University of Colorado on geochemistry. And then I actually got a DSc from Durham. So I went the full cycle, you know, of degrees and so on at the various institutions, three continents.
That's a pretty good background.
Could I just say one thing here, if Peter doesn't...
Go on, Herbert. Can we stop you? Yeah, carry on.
Peter came back to ANU to work with the man who I said quite a few years later to the then Vice-Chancellor was one of those most imaginative guys around. And the Vice-Chancellor was shocked because somebody else in that institute had said the exact opposite.
That's ANU.
Do you think your sort of previous career was a good preparation for CCS?
Well, yes, it was, because I really focused on sedimentary geology. I mean, you know, you did hard rock and soft rock geology when you're doing your first degree and so on. But I very soon settled on that I wanted to work in sedimentary basins. And you couldn't ask for a better place to start. And actually, I also started in hydrogeology for about 12 months. And that also is a fantastic thing to get involved in if, you know, ending up looking at CO2. So a combination of hydrogeology, sedimentary geology, oil and gas, I mean, all those sorts of things came together and really provided a really excellent foundation for looking at some of the things we do in CCS.
And I mean, more recently, what apart from the current wave, what do you think was the CCS high spot that you've had so far in your career since the late 1990s?
CCS high spot, let's think. Well, I guess conceiving of and actually developing and bringing to fruition, along with other people, of course, but who did all the hard work, but, you know, conceiving the whole idea of what became the Outweigh Project. And you know, at that stage, a lot of people said, well, there was this wonderful combination of a CO2 well, which was sitting just 2 kilometers away from a depleted gas well. And other people said, well, you know, no point in putting gas in the ground when it's already gas. You want to get the CO2 from a coal-fired power station. That's what you should wait for. Well, if I'd waited for that, I'd still be waiting. And there would be no Outweigh Project. There would be no 20 years of research since then. So, you know, that probably is the thing I get the most satisfaction out of.
I mean, why do you think they bothered with that for a research project? It seems missing the point, doesn't it, really?
Sorry, John, I didn't.
Why do you think they bothered with that sort of tokenism of getting the CO2 from a coal plant? When it's
yes. Well, at that stage, the coal industry decided this was going to be its savior, and they wanted to really grab onto CCS, and they were a bit nervous about the gas industry, because they saw themselves as competing directly with the gas industry. So, you know, they didn't really want to be associated with the gas industry, and what I was putting in place was really, you know, based on the gas industry, if you like. And that was something that I think tended to hold back the progress of CCS. I mean, in some ways, if the oil and gas industry had got more engaged in it at an earlier stage, I think we'd be much further on. So there's a bit of blame on both sides, I think.
Yeah. I mean, certainly I can remember oil industry would not touch a project that involved coal. CCS project that involved coal, they were very, very clear they wouldn't do that. Yeah. That's right. So that has been a problem, and the, you know, calling it clean coal and trying to relabel CCS clean coal, and I think Peabody even called it green coal. You know, that sort of thing didn't do any good, I think, in terms of taking CCS forward. It needs to be called what it is. You know, we have to explain it, and it hasn't done any good to try and hide it under a green wash, if you like. Yeah.
Well, may I just, sorry, for one sentence to say, Peter's being a little modest. I think he set up what was arguably the best project of all and best managed project, and was extremely good. And the only problem was people didn't realize just how imaginative he had been and how good it was.
Oh, thank you for that, Herbert. I'll ask you to put it in writing sometime.
It'd be a good reference for his next job, Herbert. Okay, well, thanks very much for telling us a bit about your past. I'm sure we could have gone on a lot longer, but I think, Peter, if you don't mind, give us an update on CCS in Australia.
All right. Okay, and thank you for the opportunity to do so, John. Now
thank you very much for coming to talk with us.
Hope this is going to work.
So if we could, everybody else mute and switch off videos to keep the bandwidth going, please.
Okay. Well, I was asked to provide this overview of what's going on in Australia, and I think it said CCUS. And so I should make an apology and say there's not much about you in here. That's not to say there isn't activity going on in Australia in terms of mineral carbonation, and there's quite an interesting program going on in Newcastle at the present time. But overall, the level of activity in the U part of it is really quite modest in Australia. And so I'm going to be sticking really with the CCS part. And even more than that, I'm going to be sticking primarily with the storage part of it. And again, that's not to say there isn't activity going on in capture. There is, but it's at a much more modest level, which actually I regret. I think there's a need for more activity in capture, actually. But there's this view about that says, oh, well, if we're going to capture CO2, then we'll buy it from overseas. We'll buy the technology from overseas. And I think that's a rather short-sighted view. You need to be an intelligent customer at the very minimum. And also there are certain circumstances which are going to be site-specific and coal-specific or gas-specific or whatever. But anyway, that's the way it is. So I'll talk a little bit about capture, but mainly I'll be talking about storage. And let's see, what I'd like to do is this. So what we're going to do is we're going to start here, and we're sort of going to go round from the southwest hub through Gorgon into the northern Australian one. Then we'll go down here to central Australia, then over to this area here into Queensland, down New South Wales coast to Victoria and the Carbon Net project, and finishing up here with the Outweigh project. So that's what we're going to do. We're going to go around Australia sort of in a clockwise direction. Starting off the southwest hub, and that's had work going on for 10 years now, looking at a formation called the Leisure, and looking at its suitability for storage. And it's a very different sort of storage site in that it's got no seals. It's just got thousands of meters of sandstone. So the whole concept there is that you'll get residual trapping as it gradually moves up and as it gradually migrates. And the latest studies show that injected CO2 stops migrating through the formation after about 500 years. So, there is an element of uncertainty about that, but there does appear to be a good opportunity for actually storing CO2 at this site. Now, one of the things that's happened there is that some of the industries that were interested in this have closed up. For instance, there was an oil refinery there and so on. So that's meant that this project is placed in a sort of a care and maintenance basis, I guess. But there's a lot of work there, a lot of core's been got, a lot of stuff's been written up, and it's a nice story that we have there. So that's the first one. So that's ended up as more of a research project, but underpinning it is a commercial opportunity. And with the opportunity, they started looking at it from the point of view of 800,000 tons a year of CO2 for 30 years. But it's got a lot more capacity than that. But as I say, it doesn't have a seal. And therefore, you've really got to be able to persuade the regulators this is going to work. Going on to Barrow Island, this is I just put that picture up there to show you the scale of the thing. This is primarily an LNG project, of course, and there it is. It's tens of billions of dollars worth of expenditure, and and they're producing, getting on for 16 million tons of LNG a year, most of which is exported to Asia. And the reason for this development is that the CO2, the gas has about 14% CO2 in it. Now you've got to get rid of the CO2 if you're making LNG anyway. And so the view of the state government was that they should not just vent it to the air. And so it became a condition of the planning approvals to actually put in a storage site there. And so right now, they drilled a number of wells. They started injecting in 2019, I think it was. And the storage site is now injecting 3 to 4 million tons of CO2 a year. So it's by far and away the largest project in Australia. In fact, it's potentially the largest storage project in the world at the present time. So it's a very important one. It was controversial because it's a nature reserve and so on. So they've had to have strict quarantine regulations and so on. But obviously you can't do anything about the footprint of this, of the Barrow Island LNG plant there, and that's it. So they're storing it about, I think it's about 1,500 meters, 2,000 meters depth. And so far they've had no problems with the storage side of things. There were some delays in developing in actually starting the CO2 injection. And a lot of people tried to represent this as a problem with storage. There was no problem with storage. It was all to do with faulty welds and the fact that when you put CO2 anywhere near them, you know, they sort of went to pieces, or at least it damaged them anyway. So they had to actually stop injection of CO2 for about 18 months. But I reiterate, nothing to do with the storage side, nothing to do with the storage process. It was all to do with some of the pipe work in the plant. So that's going along well. There's not been a lot published on it, which is a bit unfortunate, because I think they've got a good story to tell, but they regard much of what they're doing, I guess, as commercial in confidence. And so it is difficult to find out a lot about it. Nonetheless, that's underway. It's literally on the desert island. And that desert island is, as I said, is a nature reserve. So it's a pretty impressive project. And it's being undertaken with Chevron as the operators, but there's a number of other oil and gas companies involved in it too. So moving on around the coast, north of Gorgon, we have what's called the Petrel Sub-Basin. And for those of you who may or may not know Australia, this is going towards Darwin. So the Northern Territory is a little bit further over this way. And most of the actual gas fields in this area have a high CO2 content. And it's actually, that's a trend that goes right the way through from Australia through to Southeast Asia. So many of the wells in Indonesia and also in Malaysia and Vietnam also have very high CO2. And if there's going to be, a growing oil and gas industry, or a growing gas industry and a growing LNG industry, it is a region that's going to have to embrace CO2 storage. There's no two ways about it. So in the case of this area, Evans Shoals, one of the big fields, has 28% CO2 in the gas. So you just cannot really get a social license to let that amount of gas into the atmosphere now. And so they're looking at it from the point of view of CO2 storage. And recently, Transborder, a company, have come forward with a proposal to make this a major CCS hub for Northern Australia and also Southeast Asia. So in other words, to meet the needs of not just the Northern Australian gas industry, but also the needs of some players in the Southeast Asian industry. So we'll see how that one goes. There's certainly a lot of capacity in the overall area, a lot of quite nice sediments for injection and storage of CO2. So that's something that's really only just recently been developing. So moving on now, we'll move to this area there now, which is the Cooper Basin. And here we've actually got you've got a basin, then an overlying basin. So the Cooper Basin is the lower basin, and then you've got this Eromanga Basin, which larger basin, which really covers a lot of the area that is the Great Artesian Basin. And the gas is in this part of the basin here, in the red. That's all gas. And you can see there's an unconformity here and another unconformity here. Now there is some oil. The oil is green in these some of these shallower basins. The area has been there's been a lot of oil and gas activity in this area. You can see, I don't know how. Are you seeing this this thing on the bottom here where I've got the? Or is it? Am I the only one seeing this bar across here? John, can you?
Yeah, it sort of looks okay to me.
You say you can see the bar there?
So we can see the picture and we can see the text under the picture, but that's about it.
Okay, all right. So, and again, this basin is typically high in CO2. I mean, it can be 30 to 40%. For a long time, this was just emitted. But finally, people are saying, look, that cannot carry on. So what's happening now is that they're looking at turning it into a storage basin. They've got a lot of information there. They've got 160 gas fields, 65 oil fields, or 75 oil fields. They've had, I think it's almost 2,000 wells drilled in the basin. So there's a lot of knowledge there. So you've got the advantage of it being a brownfield site, if you like. And so this is getting a fair bit of attention from a company called Santos, an Australian company, but BP have now become involved in that. It's unclear the extent of their involvement and so on, but they're certainly now involved in some way with Santos in this basin. There are opportunities for EOR, enhanced oil recovery in this basin, CO2 EOR, and that may act as an initiator of the storage activities here. But they've got a lot of the infrastructure already. They've got a lot of wells. They've got CO2 separation plants. They've got lots of drilling equipment in this region. So, I mean, it's desert and there's not many people around, which is also an advantage when you're wanting to put CO2 in the ground. But they do have to persuade people that it's actually safe to do it, because if you remember, you've got the Eromanga Basin over the Cooper Basin, and the Eromanga Basin is a major groundwater basin. So whatever they do, they have to persuade the locals and the regulators that they're not going to damage in any way the overlying major aquifers of the Great Artesian Basin. That's something I'll come back to in a minute. So that's, again, they're looking to develop this as a storage hub, and geologically and for a whole range of other reasons, it makes a lot of sense. The only problem is, as you can see from this picture, there isn't much industry around, and they're going to have to pipe in CO2 for considerable distances, perhaps of the order of 1,000 kilometers or more. So that obviously adds to the cost, but that may be offset by a relatively cheap storage opportunity. The other thing that's going to potentially impact upon this is that they are, it's not called a price on carbon, but it's similar to the 45Q sort of thing in the United States, where they're talking about providing what do you call it, a subsidy or a price or whatever on each ton of CO2 that's geologically stored. But there's still discussions going on that issue. So this is just a slide I put in, just one of the organizations. We've got several organizations involved in CCS, and many of you would know about the Global CCS Institute. We've also got the Australian National Low Emission Committee or Council. And this is where this shows their spread of money here. And they've spent $100 million worth of cash and $100 million worth of in-kind support. And so it's been a significant contributor to CCS R&D. Then, of course, you've got the CO2 CRC, which has been a major contributor to CCS research in Australia, not just at Otway, but in a number of other areas too. And then you've got the individual organizations, the number of universities working, Curtin University in Western Australia, Queensland University, ANU, University of Melbourne, University of Adelaide. So there's about 6 universities that are working in the CCS area to varying degrees at the present time. So the Shurat Basin, we're now over in Queensland, and here the focus of attention is the Shurat Basin, which is a Jurassic basin. Again, it's been an oil and gas area for some time, and this has helped it in many ways, although it all depends on the way that they've been perceived by the locals. In some cases where the locals have had a poor experience with dealing with oil or gas companies, then this can count against it, of course. But they started off by looking at this area in the northern part of the Shurat Basin, and in fact my next slide I think shows this. But it ended up with them having to move south for various reasons, and I'll go into that in a minute. The other thing that it's got in this area is an opportunity for enhanced oil recovery. Now, this is nothing special, of course, in North America, but Australia's never really done any enhanced oil recovery, and there's some good reasons for this, not least being the nature of the oil, which is not a heavy oil. It's a very light oil, and so you get very high recovery rate, very high primary recovery rates from the fields that you've got here. And putting CO2 in there doesn't help that much, particularly if you're paying for your CO2. However, if you're now going to start getting paid for putting the CO2 in the ground and you're able to get enhanced oil recovery as well, then that obviously is a benefit. Like in many places, the debate then becomes, well, are you actually going to be ahead with your CO2 budget if you're going to be putting CO2 in the ground, but then you're going to be getting oil out of the ground, which will then be used and produce CO2. There's a number of studies that have said, well, it actually works and you can get negative emissions from associated with the EOR. But I think it needs to be considered a little more clearly, and I think it needs to be considered by a really impartial sort of group to address the issue. It's always a difficult one to argue, and I'd much rather we could argue from the strength of real numbers that can be justified, that are produced by an impartial organization. So it really means it's not the oil and gas industry that produces the numbers. It's got to be somebody else, but then the oil and gas industry is the group that has all the expertise. So you're in a bit of a quandary. So it needs to be reconsidered anyway. So that's the Shurat Basin, and there's quite a lot of work underway, mainly by a company called CTSCO, which really is Glencore, which you probably know. And that's been doing a lot of work in this area. And of course, that's underpinning Glencore's activity in coal. So what happened here was that they started off in this northern area, and you'll be able to look at this in your leisure if you ever want to look at this again, and see what the detail is. But basically, you're going down with fairly shallow wells here, and you're getting good reservoir rocks. But the trouble is those reservoir rocks were also near to where you've got really important aquifers. And so there's a lot of unhappy people about the thought of CCS having a negative impact on groundwater. And people get very emotional about their groundwater, and understandably so. Their living depends on it. And so it's not something that can be taken lightly. And so the problem was they were actually drilling and proposing to put CO2, or looking at the possibility of putting CO2 into freshwater aquifers. And so that just hasn't gone anywhere. Well, what's happened now is they've moved further south, which I think is a much smarter way to go. Now they're into much deeper formations now. It's still the precipice sandstone, which is a very nice aquifer, and they're going down to about 2,200 meters, looking at the aquifers, at the reservoir rocks, not the aquifers. So they're more expensive wells, but you don't have the groundwater issues. And also they have other issues that benefited lower population density and that sort of thing. So they've now focused their attention in this area. They're getting really good porosities in sandstones at 2,000 meters in some of these synclines. So it's looking quite promising. Again, the concept there is of a CO2 hub and taking in CO2 from a number of sources. Now, in this area in particular, they have got some relatively young coal-fired power stations. And so the issue then is, well, could you retrofit, or alternatively, they're thinking of building a new coal-fired power station. And this is a difficult one in the climate in Australia, because really there's very little support for any further coal-fired power stations. So that may never happen, to be perfectly frank, if it's based solely on coal. But people are now starting to look at, well, rather than going using thermal coals, perhaps we need to look at hydrogen generation from coals. And so they're now turning the equation around a little bit and looking at it from that perspective. But it certainly has the potential to be a CO2 hub if some of these things can come together. Oops, sorry. The next one is a more speculative one. It's one that I have to declare my hand and say that I've been acting as an advisor only for a matter of weeks to a company called Advent Energy. And Advent Energy has this area off Sydney and Newcastle on the New South Wales coast. And it's about, I don't know, 30 kilometers to 50 kilometers offshore. And they've got a number of areas where they've got quite deep sediments in this area. Now, there's all sorts of issues facing this. I mean, not least the fact you've got some, nice surf beaches in this area and so on. And so the question inevitably arises from people, well, are we going to see these rigs when we go surfing? The answer is no, you're not, in that it's going to be further offshore than that. But nonetheless, it's a very emotive issue. But the way that I view it is that it provides an opportunity to assess this area for CO2 storage in a way that it's just not been possible. There's no way that anybody is going to drill a well solely for CO2 storage in this area. So what I'm involved in is looking at, can we assess the storage capacity of this area, essentially on the back of a wildcat gas well? And the answer is maybe we can. So this is the study that's going on at the moment. And as you can see here, there's quite a lot of sediments. And the other interesting thing is that elsewhere in New South Wales, which is the major emitter of CO2 in Australia, there has been no viable storage site identified as yet. That doesn't mean to say one won't turn up, but at this stage, it has not been identified. And this I think is a very minimum, rather than looking at areas that are 600 or 700 kilometers away from the major emission sources. We should at least look at this area and then make a decision whether it's worthwhile proceeding to look at storage in more detail or not also. Because this is only 30 or 40 kilometers away from these emission sources, as opposed to 600 or 700 kilometers. So it does have some attraction. And here I put, this really is the 800 meter mark. In other words, you know, subcritical, supercritical. So that's an important boundary. As you can see, there's lots of sediment down here. It's poorly described by the seismic here. And also you've got some things here which may be gas chimneys. So that would be a potential problem if that gas chimney was going to be a source for escape of CO2. So you'd have to look at those sorts of issues. I'm not saying any of these are insurmountable. And we don't know enough about this area at the present time, which is why I'm interested to see if we can learn more about it. And so this is the whole point of this, is to use the Baleen well, which is a well they're going to drill for gas, to start to assess the area for CCS prospectivity. And I've listed there a number of things you need to do in addition to looking at the gas, in other words, taking a gas well and then saying, well, let's build on that gas well to do a number of other things to really assess this area. So we'll see how that works out. So that's probably the most speculative thing I've put up here today. And then we have the Carbon Net project, which is in Victoria. And this is a fairly well advanced project now. And it's got 2 areas which have quite nice offshore storage opportunities. They're called Pelican and Kookaburra. And they've each got capacities of, probably more than 100 million tons of CO2. And the whole idea of this area is, again, to be a hub, in this case, an offshore hub. It's not very far offshore, probably about 10 kilometers, 20 kilometers offshore, I guess 20 kilometers, to take CO2 from a number of sources. And one of the particular sources that's being speculated on at the moment is hydrogen. And that's because you can very readily produce hydrogen from brown coals in this area. And these are some of the, in fact, I think they're the second largest brown coal deposits in the world. And so it's cheap and it's easy to mine and so on. But of course, it's a polluter when it comes to CO2 if you just burn it. So they're now looking at, can we, through gasification and CCS, actually produce a low CO2 hydrogen. So that's the whole concept in this area. And they've got a fairly major project going called the Hydrogen Energy Supply Chain, which is really the, if you like, the Japanese end of the project. And the whole concept is to produce hydrogen from the lignites in this area, put the CO2 offshore into a storage site, and then ship the hydrogen to Japan. And there's a ship that's under development at the present time to do just this. So we'll see how that works out. But at the moment, it's an interesting area, an interesting development. And they've got a lot of really nice data. I mean, this is the 3D seismic, which shows you exactly what's going on. And for those of you who aren't geologists and so on, this, for instance, is showing you a paleo channel. And this area was probably a delta of some sort. And these are all the sands and so on. So you've got a very nice picture. And from this picture, you can work out that it really is a very secure sort of site with lots of nice seals, lots of nice porosity and permeability. So it's a very interesting sort of area. One well has been drilled in the area. That was last year, and that was drilled down to, gosh, if I give the number, I'd be wrong. So it's 1,500, 2,000 meters, and they've spent about $150 million in this area. So it's a serious sort of project. The present time, it's mainly the federal government and the state government that are supporting it. But they're getting increasing interest from industry, and that, of course, is what they're hoping to move into a real industrial type development here, which would obviously not be through the government; it'd be through privatization of the whole thing. So that's the test well that was drilled, and that was drilled about here, as you can see, the offshore appraisal well. And that was very very effective and very convincing. So they're confident they could inject about 5 million tons of CO2 a year into these structures. So they could take a lot of CO2. And finally, the Otway project, and some of you probably sat through the meeting a couple of weeks ago, so I won't spend a lot of time on the Otway project. This is where that one is. Melbourne's here, and the Outweigh Project is about here. It's about 200 or 300 kilometers from Melbourne. On the very scenic coast, this is a national park around here, Port Campbell. Some fabulous scenery. And this is the model. And initially, we injected CO2 into this depleted gas well here, and now we've been injecting the last few years into these saline aquifers in this sort of area here. So that's about a little over 2,000 meters. That's about 1,500 meters, and that's where most of the attention is now focused, in these saline aquifers here. The reason why we did this one is because it was the first one ever done in Australia, and so we wanted to do it in an area where we were damn sure it was going to be successful. So we took an easy option there, but we've moved now into more challenging sort of environments. And we now have, over the last few years, as you can see, the Otway 1, depleted field storage, Otway 2, saline formation storage, Otway 3 has been really looking at low impact monitoring and putting fixed arrays and that sort of thing to avoid the problems that you can have of constantly having to do 3D surveys, which can be disruptive and expensive. So they've been spending a lot of time actually doing those. And what's now been done is to create here a national facility with a whole range of facilities available. And Matthias Raab spoke about this a couple of weeks ago, and you may be involved in that meeting. But it's a very impressive facility. So why is there an increase in activity in Australia? Well, of course, it's caught up in the international trends, and those international trends are accelerating, if anything. So there's been a pickup. But not sure which comes first, chicken or the egg in this instance, but in September of last year, in other words, about 6 months ago, there was a low emission technology statement from the federal government, and they outlined 5 priority technologies for the next 5 years. And they also put together what they called stretch goals, and they put those in economic terms. So they're stretch goals, which of course really identify the technologies you're talking about. Hydrogen production under $2 a kilogram, long duration energy storage, less than $100 per megawatt hour, low carbon materials such as steel, low carbon steel, or low emission steel, I should say, $900 a ton, low emission aluminium under $2,700 a ton, and CCS CO2 compression, transport and storage under $20 a ton, and then soil carbon storage under $3 per hectare per year. So those are the stretch targets. And this was the first time for quite a while that the government has said that CCS is now part of its targeted technology developments. And so that has helped to push things along. They are going to be producing a more detailed statement on CCS. It should have been out actually at the end of last year, but that hasn't happened yet, so it should be out fairly soon. And the government is now recognizing that CCS is a real opportunity for Australia. We have the right sort of geology, and in some cases we've got the right sort of skills as well, in quite a few cases perhaps. And I think that a few years ago, I would say that Australia was, in the top 3 or something like that, and that's slipped in recent years. There's no question. And so I hope it'll be an opportunity for Australia to reassert its skills and impact in the CCS area. That's certainly my hope. So there we are. That we've got government statements that are now starting to back up CCS, they've got plans for actually putting, it's not called a price on carbon, it's called Australian ASSUs, I think it is, and I can't even remember what the acronym stands for now. But it really means that you'll benefit to the tune of, I think it's about $16, $17. So it's nothing like the US figure at this stage, and they may have to modify that to actually pay for people to put CO2 in the ground. But nonetheless, we're moving in the right direction. And I think that's probably the last slide. And I've probably gone over time, John, and I apologize for that. But hopefully that's given you a bit of a feel for what's going on there, the sort of, you know, the big picture of CCS in Australia. So thank you for your time. John?
That's great. Thanks very much, Peter. So now we've got plenty of time, so you can have some questions. So Anna, do you want to ask your question? Can you introduce yourself before you do it as well?
Hi, Peter. Thanks for an interesting presentation. I'm Anna Petrel. I work for Tindaka, so it's a lower completion service company, but I'm also doing my MSc looking at the possibility of a downhole choke to maintain CO2 in liquid form. And I'm just wondering what phase the carbon dioxide is being injected in these areas, and if there's been any issues with the Joule-Thomson effect, and if so, how they've been mitigated or been looking at solutions.
Well, I mean, you know, it's really the pipelines where that sort of thing comes into its own, and that's where the concerns have been expressed and so on. But they've been putting CO2 in pipelines for a long time now, and fairly safely and effectively for the most part. The interesting thing, and we missed an opportunity, I have to say, with the Outweigh project, but because what we did there was we actually did what's called a drill stem test, which really means for 2 or 3 days you let out the gas. And so we had this, you know, 90% or so, 80 to 90% CO2 being emitted, and you got the Joule Kelvin effect in spades then. And we ended up with this great big pile of CO2. And because it was very cold, of course, it then froze, and there was a bit of rain, and the rain froze on top of that. So it ended up with this great mound of CO2 covered in ice, and it sat there for a couple of weeks until the regulator said, well, you're going to have to get rid of that. So we actually had to cart it away in trucks and take it to the local dump, where of course it would then have been then turned into gaseous CO2. So that's the sort of thing you can have with, which is not the sort of thing you were thinking of, but then that's the closest we've been to the Joule Kelvin effect. But it was, you know, it was not a major issue. I mean, we were letting out a lot of CO2 there, but there were no real safety issues there. For us, we could see where the CO2 was, we could monitor it, and so on. So it's not been a major focus of our concerns so far.
But do you got a comment to add to that?
So you're asking me?
Yeah, I got a message that Herbert had a...
I did want to make 2 remarks, Peter, other than that was a very broad and interesting and stimulating talk. The first you mentioned about Gorgon, and I wanted to say that, as you know, I was a Selby lecturer in 2018, and the first place I spoke was about climate change in Perth, and I mentioned that Gorgon existed, but I didn't know very much about it because they kept everything secret, which was a great pity. And a man came up to me at the end and he said, I'm really quite a senior person in Gorgon and I can understand what you're saying. I'll let you know some of the data, the sorts of things that you want. And I said, gee, thank you very much. That would be nice. And he rang me about 3 or 4 days later and said, I'm terribly sorry. I've gone to see my superiors and have said, no, you can't give out anything. And I was somewhat disappointed. The other comment, if you don't mind, I'd make, and I think you'll find this interesting, and I'm sorry that I didn't involve you, as you'll see. When ScoMo won the election, became the Prime Minister, after about 3 or 4 weeks, I wrote him an email, and I started by saying the two of us went to the same school together, and I frequently went back to Sydney High and gave talks, so it may even be that we've met and know each other. I didn't think that was true, but I put it in as a starter. And I suggested that wouldn't it be an interesting idea if the Australian government put out a fair amount of money for a call for research into CO2, but with a commercial side to it. How Australia may, by CO2 appropriate usage, could really make some money. And I said this way the government could put up a relatively small amount of money, though a large amount of money by my terms, and get a huge return. I sent this to ScoMo, who never replied. I sent a copy to Alan Finkel, who within a minute emailed me back saying, fingers crossed. I didn't know Alan quite well enough then, but I thought mouth open would be much better, Alan, than fingers crossed. And I have said that to him more recently. I sent it to a copy to the president of the Australian Academy, no reply. To the Minister for Energy, no reply. To Barry Jones, my good friend, who wrote back and said, Herbert, you're crazy. The government's not going to put any money into this. In some sense, he was right. Do you have any comments? I should have sent it to you. That was a mistake.
Well, I probably wouldn't have sent you any money.
It's not what I would have sent it to you for.
Although I have sent you money in the past, I seem to recall, for airfares and things like that. Well, for a long time, I mean, and particularly at the time when ScoMo was coming in and so on, CCS was still a dirty word. I mean, yeah. It really was. It was not. It was less than flavour of the month. It was, you know, it was not seen as viable, and the government didn't want to do anything about it anyway. I mean, the government's still uncertain about what it's going to take to the Glasgow meeting at the end of this year, for example. But we're starting to now see. All the state governments have actually signed up to net zero by 2050. And even the federal government is now talking about net zero. It's just not talking about 2050 at this stage. And that is certainly becoming another source of impetus to CCS, because people are now accepting that you're not going to have net zero without CCS. And certainly that's a call that I'm taking to the federal government now and saying, look, you know, it's whether you like it or not, net zero by 2050 will be accepted internationally, and the only way you can get there is by inclusion. It's not the only route, obviously, but inclusion of CCS. So we'll see how that goes. I mean, I think it's getting some uptake.
Well, I hope you're right, Peter. And as we've said before, you're an optimist and I'm a pessimist, which is a pity. I feel strongly my view is unfortunately appropriate, but I hope you're correct and I'm not. But I'm very nervous about these statements by governments and industry. Look, we're going to do things in 2050. By 2050, there'll be net zero. And I've made similar statements to my friends by saying, I'm getting going, I'm thinking carefully, you'll see, by 2050, I'm going to get a Nobel Prize.
Well, I think that the UK is a standout in having its roadmap for getting to net zero by 2050. And that's really the acid test. And well, the acid test is really to stick to it as well.
Yeah.
But nonetheless, it's got a plan, it's got numbers, it's got an intention to get there. It's put a number of the levers in place to get there. Now, that's not happened in most other countries. Most other countries signed up to it and not really put anything else of substance behind it. And that's, you know, hopefully after Glasgow, that might change.
Okay, just going back to some technical issues, Radin has a question. Could you ask that, Radin, and introduce yourself? Oh, Peter, do you want to stop screen sharing and then we can see you a bit better?
Stop sharing. Yes, sorry. Yeah,
Very good.
better, right.
Radin, do you want to? I can only see you as Radin.
Actually, I'm using my name is Mortaza. I'm using my son's PC, and his name is Radin. So I've got two questions. One, I would like to know whether you use any chemical while you're injecting CO2 for any reason of absorbing better CO2 in the ground, or for any purposes, because as you inject anything into the ground, or you know, you basically take oil and gas from any well, you need to inject some sort of chemicals. And the second question is the prices you gave us about $2 hydrogen, $2 per kilogram, and I think was $20 for CO2. Are you considering the cost of the construction of the additional equipment as well?
Yeah, that's a total cost amortized over however many millions of tons of CO2 you're dealing with. So yes, in theory it does, and it's a stretch target. There's no question. I mean, we're quite a long way away from there yet. And that was, I mean, it was Alan Finkel, who Herbert was talking about, was really the instigator of the stretch targets. I think it's a good idea. It's hard to know how realistic they are. And there's no time frame put into those numbers as far as I'm aware. But that's the nature of a stretch target. I mean, we're a long way away from $2 a ton. $2 hydrogen as well. But you know, it's an aspiration, and hopefully it becomes more than an aspiration. It actually becomes a real target. As for your first question, the answer is no, not to my knowledge. There have been some problems. I mean, we had them at Otway, and I'm sure they've had them at other wells, where we had problems with injectivity. And that was because you did have some reactions with some of the, the rocks that you're injecting into. And it is necessary then to put things into the well specifically to help the injectivity, but you don't put that in with the CO2. You actually inject that separately, and it's just a slug of material that actually removes the problems that you've got, which are usually problems near to the well, and that's sometimes those problems are due to the Joule-Kelvin effect. To come back to that one, because you get this tremendous cooling, and that can have an impact. But no, there hasn't been any attempt to put anything into the CO2 to help the injectivity of it. It's pretty good it's got low viscosity and so on. So it doesn't actually need a lot of help once you get it into rocks with some permeability and porosity. It's a very fluid sort of fluid, if you like.
Thank you very much. Thank you.
Okay, Peter Ame, can you want to ask your question? Introduce yourself. Are you okay to carry on for a little bit longer, Peter? By the way?
Sure.
Yeah.
All right. My name is Peter Ame from the University of Edinburgh, a PhD researcher. Thank you, Peter, for the very extensive presentation. But my question is if you have any thoughts on the effect of geothermal conditions on CO2 during the predicted 500 years of migration that you said earlier.
You can see the thermal signature of the CO2 for quite some time after, and I think CSIRO has done some work on this. So yes, you can see the cooling effect. And I don't think it's been extensively researched, but yes, it's there. It may be a useful signature for looking at some effects. But it's yes, the short answer is yes.
All right, thank you.
Okay, Paolo Orsini,
Can you hear me?
can you introduce yourself, please, as well?
Yes, yes. My name is Paolo Orsini, and we work from OpenGASIM. We develop and support a simulator for CO2 storage. And my question was, I mean, in the Outweigh project, I understood that you started injecting in a depleted gas field, and then you moved into saline aquifers. And I suppose probably because of greater capacity. Can you comment a little bit on the other projects you mentioned? If there are plans as well to move to saline aquifer, especially you mentioned some for CO2 in non-soil recovery. So basically, what are the main kind of sites that you're looking at, if depleted gas field or saline aquifer?
Well, yeah, there's no question that going into areas where there's been oil and gas activity is a real benefit from the point of view of having a large database and so on. You're very confident of your reservoir quality and so on, and your seals, all that sort of thing. So it's a real advantage in actually being in oil and gas areas. Within that, yes, there's real focus on saline aquifers, and as I mentioned earlier in the Shurat Basin, where you try to use a freshwater aquifer, you get a lack of enthusiasm from the locals, to put it mildly, and it becomes quite an issue. I mean, in a country that's as dry as Australia, in many parts of it, water is a really valuable commodity. So whilst pore space can be a valuable commodity, it's a matter whether you use that pore space for CO2 or whether you use it for water. And a lot of people would say, well, you should use it for water. So that always takes a priority. So that's why you certainly want to look at formations that are low in drinking water, if you like, or high in salt, if you like. EOR, other than a little bit in the Shurat Basin and in the Cooper Basin and the Central Australian Basin and the Southeast Queensland basins, not a lot of interest so far. I mean, for instance, the main oil and gas fields in Australia have been Bass Strait down in the southeastern part of the country, and they have been, they've got a number of giant oil fields there and so on, but they've had, as I mentioned earlier, very high primary production. And so there's been no incentive to actually start looking at an enhanced oil recovery using CO2. But that could well change. That equation may well change as you get money for putting CO2 in the ground and you get EOR out of the ground. So it's a movable feast at the moment, and I think it's a matter of watch this space. But as I indicated earlier, it does raise this issue of it'd be nice to have some numbers to show that you can actually get negative emissions from CO2 EOR. If that's the true situation, it'd be very good to have definitive numbers that would show that's the case. I mean, I can see how it could be the case just by putting a lot more CO2 in there than you really need to produce the amount of oil that you can produce. I mean, previously, the way that it's worked is that people have been optimizing or minimizing the amount of CO2 they use because the CO2 has been a cost. If you turn that equation on its head and you say using more CO2 is a benefit because you get more money, then that starts to make a lot of sense in terms of putting more CO2 in the ground. To such an extent, you start getting negative emissions.
Thank you.
Yeah. Peter, just sort of following on from that, you say negative emissions, but I guess what you actually mean is a net storage of CO2 in that case. But how much discussion has there been about greenhouse gas removal from the air for actual negative emissions? Engineered greenhouse.
There's been a little bit, and you know, at least one company, BHP, have put some money into that. So you know, it's starting to get a bit of attention. I mean, the benefit is, of course, in a country like Australia, where you've got you can actually take the rather than having to pipe the emissions to some distant storage site, you can actually put either your wind turbine or your solar system on top of the storage site, and then inject your CO2, you know, from a direct air capture plant or whatever. So you know, people are now starting to think about that. It's still got a way to go. I mean, it's still pretty expensive, and it takes a lot of power to capture and store not a lot of CO2. So I'm not cynical about it. I'm just cautious that it's, you know, we shouldn't rush off and think of it as the answer. But conversely, we should keep it in the discussion there. We should see it as something that needs to be further considered.
Yeah, that's.
But I reiterate, there's no significant direct air capture project that I know of going on in Australia at the moment.
Yeah. Okay. Any more questions from anyone? Otherwise, I think we're getting a little bit past the hour and people are having to leave. Okay, well, I think that's about it, Peter. Thank you very much for the oversight. Yes, I can remember coming to Australia in 2003, and as you say, very definitely leading the field then, and still very active. So it's good to see that.
Still very active, but not leading, or being in the leaders. I think that you know, the UK has progressed significantly in that period of time, and I think Australia has regressed to some extent.
I mean, it depends how you put it. If you're storing that much CO2 at Gorgon, that's still quite leading, isn't it, in some ways?
Well, that is certainly true. Yes. I mean, if you just take Gorgon alone, you say it's still the leading storage site in the world in terms of the amount of CO2. I think Exxon actually have a site where they might put more than that in, somewhere in the Western United States, part of the Outweigh project. But it is pretty much a leading project.
Yeah, for actual intentional CCS, I think that's obviously far and away the biggest. So they needn't be too modest.
Yeah. Okay. Well, no, and nor should I undervalue the Chevron Gorgon project. It is an outstandingly good project, but I just wish that they would actually provide a little more information, which is, you know, the point that Herbert was making earlier. And it's one that, you know, when they don't provide the information, people will make up their own stories on these things, and we saw that.
Absolutely.
And so that's the frustration we have sometimes. We're having to, you know, defend the project without necessarily having the necessary numbers to defend the project.
I might just add to that, I don't see any advantage to Gorgon keeping the data to themselves.
No, I would agree with you. I would see benefit in having it much more open, but they've got a $40-odd billion project and hanging on to a $2 or $3 billion storage project, and they don't want to mess up their main project, I guess. So they're being, you know, they're exercising an abundance of caution at the moment. I just hope that will change in the future.
Okay, well, you can come and tell us about it, Peter.
Right.
That'd be great. Okay, well, thank you very much, Peter. That's really great. It's also, you know, nice to see somebody with a slightly warmer background that we've got here in the UK. So a reminder that summer exists. Good time of the year. Well, we'll have to get you on in February regularly. I think it's. Okay. So thank you very much.
Okay. All right.